A mass of 20 kg is dropped from a height of 1 meter on the center of a small rigid platform as shown in the figure. Two steel rods are supporting the platform. These steel rods are 25 mm into 50 mm in cross section and are 3 meter long. If one half of the energy is effective in producing the stress in the two rods, we have to find out the equivalent static load, deflection of the platform, and assume capital E is equal to, that is modulus of elasticity, as 200 GPa for steel rods. So half of the energy is effective in producing the stress. So this is important part. We have to first find out the energy and then make half of that to find out the value of stresses or value of static load and deflection of the platform. Now as the weight is falling from a certain height, it is the case of impact loading. So let us see the figure which is given in the example. So we are having total length of the bar as 3 meter and 20 kg mass is falling on this rigid platform from a height of 1 meter or 1000 mm. Remaining distance will be 2000 mm. These are the two steel rods. So this is the first steel rod, this is the second steel rod, which is having cross section of 25 mm into 50 mm. So 25 into 50 mm square will be the cross sectional area. So it is falling from this height of 1000 mm on this rigid platform. So W is equal to mg, that is mass into gravitational acceleration. Mass is in kg and gravitational acceleration is in meter per second square. Cross sectional area is 25 mm into 50 mm, that is mm into mm, so it is mm square. Area is always in mm square, so it is 1250 mm square. Volume is area into length. As area is in mm square and length is in mm, so this is mm square into mm, so it is in mm cube, so it is 3.75 into 10 raised to 6 mm cube. Now doing the energy balance, when the load it falls on the rigid platform, as it is supported by the two rods, therefore 2 multiplied by the strain energy, equivalent strain energy that is stored by these two rods, that is sigma square upon 2e into volume. Now delta L will be equal to sigma into L upon E, so that we can substitute. So it is WH plus sigma L upon EE, and sigma L upon E is equal to 2 into sigma square upon 2E into volume. Right hand side we have kept it as it is. Substitute the value now. W is 20 into 9.81, that is mass into gravitational acceleration. Height through which it is falling is 1000. Stress we have to find out. Length is 3000. Modulus of elasticity is 200 into 10 raised to 3. So 2 into sigma square upon 2 into capital E, that is 200 into 10 raised to 3 MPa, and volume is just now we have calculated as 3.75 into 10 raised to 6. So this term is multiplied to 1000 plus this term is multiplied to this sigma term also. So if you make the calculations for this, then it comes out to be 72.37 MPa. So let us first see what will happen over here. So what you can do is 3.75 into 10 raised to 6. These two and these two will get cancelled out. So 3.75 into 10 raised to 6 divided by 200 into 10 raised to 3 into sigma square, that is your first term. Then this term, this particular term multiplied by 1000 will be a constant term, plus this term is multiplied to this term, that will be in terms of sigma. Transfer this term on this side, so they will become minus. Both these terms on this side, they will become minus, and then negative, that is, and you will get the term quadratic equation in terms of ax square plus bx plus c, and then you have to solve that second degree equation on your calculator to get the value of sigma, that is 72.37. If you are having any problem in solving this example, please let me know. We'll provide the complete solution for this. So sigma value of sigma comes out to be 72.37 MPa. Delta L is the instantaneous elongation of the rod, and that is nothing but the deflection of the platform, that is sigma L upon E. Now just now we have calculated the value of sigma. So here the units are sigma is in Newton per mm square, length is in mm, and capital E is in Newton per mm square. So that value comes out to be 1.085 mm. So again see the units. Stress is in Newton per mm square, length is in mm, and capital E is 200 into 10 raised to 3 Newton per mm square. So the total unit of this particular term is 1.085 mm. Now we have to find out the equivalent static load. So equivalent static load will be the load which will be producing the same effect as it is produced by the falling load. So delta L will be equal to, as far as the static load is concerned, according to Hooke's law, it is PL upon AE. So P as it is, length is 3000, area already we have calculated, that is 1250 mm square, and E is 200 into 10 raised to 3. So 1.085 will be cross multiplied by this term, that is 1250 into 200 into 10 raised to 3, and then divide that entire value by 3000, so that you will get the value of equivalent static load as 90.41 into 10 raised to 3 Newton. So total load that will be taken by the two rods will be 2 times this P. So it is 2 into 90.41 into 10 raised to 3, that is 180.83 into 10 raised to 3 Newton, or 180.83 kilo Newton.